Hey, I'm about to take this off so try to like scan it and then I could appreciate it. Hey, Trip, you did this too? Bet, appreciate it. Alright, we're about to start. So, quick little reminder, this is today, Tech Series is today. Now we on to program management. If you into PM stuff, you don't really want to code, but you want to be in the tech space. I mostly work with PMs day to day in my real job. So this might be of, of use to some of y'all who don't necessarily want to code, but you still want to be in the engineering space. So, let's see. So today we got functions. We've been working with functions in the class, like here and there, using like length, sub, string, all that stuff. But now we're gonna really start creating our own functions from scratch. Being able to make our programs like way more dynamic, way more general, and make them do exactly what we want them to do. And this is typically day to day what I'm doing. I'm writing functions that do specific jobs. So as an overview, I'm gonna go over functions and kind of like the concept behind them in a general sense. Then I'm gonna go over some of the functions that we've been using in the class to make it make sense. Then I'm gonna go over how we're gonna create our own functions. And you should see a scratch pad up there for week 8. We're gonna use that today. And there's a bunch of like practice stuff I added in there for this week. Because the only way to really get functions is to keep practicing it. You just gotta keep practicing. So functions 101. So I like to think of functions in terms of mathematics first. You know, in math we have something like y is a function of x. Y is a function of x. So we have some value x, right? We're going to pass it through some function. We're going to do some steps on it. And we're going to get an output value of y. We don't know what f of x really means yet. It could be slope-intercept. It could be square root. It could be anything. But we're going to take that value of x. That's our input. We're going to do some operations on it. And we're going to get an output value called y. So digging a little bit deeper, we know x is the input. X is our input. And y is the output. This value y is dependent on whatever x is. So if we change x, y gets changed as a direct result of us changing x, right? Without x, we don't even have a y. So we have to take our x as an input, do something to it, then we can get a value called y. So depending on the value of x, we'll get a different value for y. We following so far? Cool. So looking at a diagram of what this might look like, we start with our input. Our input is x still, using that prior example. X is our input. We're going to take that, we're going to run it through some function. This function could be anything. It could be taking x and squaring it. It could be taking x and making it negative, whatever that is. And then we get an output known as y. So let's say I had the following, right? Let's say I had 3 as my input. 3 is my input. I'm running it through some function that wants to take the input and square it. And then it's going to give me output. In this case, what would my output be? 9? 9. All I did was take x, or whatever my initial value was. I ran it through some function or series of steps. And then I got my output. Input, function, output. So thinking about something in real life, outside of math. So let's say we have a vending machine, right? Let's say we have a vending machine. Still thinking about how we approach this in mathematics terms. We took our input, ran it through the function, we got our output. In this case, we still have a input-output system for a vending machine. It's just a little different. In this case, our input is actually what we put into the machine, right? The keys that we pressing on this machine are the inputs. So if I want a certain snack, I would press the input to give me that snack, and the output would be the snack itself. In order to get the output, I need the input. Depending on that input, I will get a specific output. This is a real life example of a function. And some things to note are, depending on the value of x, Still, we know Y will change based on that initial value. So if we put in a different key, we get a different snap. And the real key thing to note is we don't know how the internals of this machine really works, right? All we know is we give it an input and we get our output. We don't really care what took place behind the screen or behind the glass. All we know is we needed to give some specific input to get our desired output. That is the concept behind a function. Give it some inputs, get an output. So now for how this might look in code. How this might look in code. So I started off with my normal imports, but I actually included CMath this time because I want to do some math. I want to do some math this time. So I'm saying on this first line in the main function, I said, give me the square root of 25. Square root in this case is a what? Square root is a what? A function. Thank you. Square root is the function I'm using. And this came from CMath. That's why I had to include CMath. So I'm saying, give me the square root, and what's my input for that one? What's my input? 25 is my input. That's what I'm inputting into the function. And we know the square root of 25 is just 5. So what this is really doing is, it's saying, boom, use 25 as your input, run that through the function. We don't know how that function works because we didn't create it. It was already created for us in CMath. Somebody wrote it for us. So we said, boom, use this input, run it through that function, and give me the output. The output in this case, we know, is 5. In the second example, I'm using the same function, so the same steps are being used, but I'm passing a different input. I'm passing a different input this time. This time I want to use 16. So I'm saying use this as my x. 16 is my x value. I'm running it through that function, and I get a different value this time. I get 4. I get 4. So the steps that it ran through are the exact same, but the input and output are what I'm changing from function call to function call. And so peep how we don't really know what the internals of this function really looks like because we didn't write it. Just like a vending machine, we didn't build it. We don't know how it works on the inside. All we know is we give it the input, we get the output. We get the input, get the output. We following so far? Yeah. So now some of the ideas behind functions. So this is where it started getting a little tricky, but ask your questions as we move along. So functions sometimes take inputs. Not all functions take inputs. So think about the difference between like the substring function and the length function. Length, we never put a number inside of those parentheses. That means it doesn't take inputs. However, for substring, we know we have to put inputs in it. So inputs are sometimes optional, like some functions don't have them, some functions do have them. But you have to know, does this function I'm trying to use require me to provide some type of input? If it does require inputs and you don't provide inputs, it'll throw an error. If the function doesn't want you to give inputs and you put inputs, it'll throw an error. The inputs have to always match how the person who created the function actually created it. And so we know functions always do a specific task. This applies to all functions. We know substring only does one specific job. It gives you a portion of an existing string. It doesn't do anything less, anything more. It gives you a certain portion of a string. Likewise with length, we know length does what? It gives us the length of a string. So you're going to name your functions accordingly. You name them based on what they're supposed to do. Because if somebody sees your function in the future, they want to be able to understand this function is going to do this specific job. This function does one specific job. And so then some functions actually do return the output. The functions that we've gone over in this class so far, like substring, length, and then the examples I went over today, all of those gave me an output. But they can be optional. So if you've ever seen void in your code, that means no output. Void means no output. So maybe take a minute, 2 minutes, and maybe just think about like, all right, what components do I need to build a function, and why would I even need a function in the first place? Like, what could its use case even be? Like, why do I need functions? Maybe take a minute, 2 minutes to think about that. And chop it up with your neighbor, bounce ideas around. What y'all think? I heard variable. What's going on over here?
Don't you need a function to create a variable in the first place?
Not necessarily. I can create a variable like int x equals 5. I didn't need a function, but like you need a function to run it. Yeah, you do. So int main is an example of a function. Mm-hmm.
That's
Yeah, exactly. All right, we back. All right, so boom. Why do we need functions? If you couldn't think of anything, I'm gonna give it away. But does anybody have a good idea of like why we need a function? Anybody read about it at some point?
Wait, read about it?
Yeah, maybe you came across functions in a book or a video or something. Nah.
But like it simplify stuff.
Simplify in what way?
Like let's say we want to do a quadratic formula. You can make a function for it instead of
Right.
doing it
Yep.
every time.
Yep. Exactly. So to piggyback on what you just said, that kind of breaks down into like a whole bunch of sub reasons, but you exactly right. So one thing is that it makes our code way cleaner. Functions make our code way cleaner. The second thing is it makes it easier to read and maintain. So a lot of times, if I take code at work and I see it's doing a bunch of like jumbled up stuff and it's not in a function, I'll like extract a lot of that code to separate functions so that when I really plug it in, it starts to read like English. Because you get to name your functions whatever you want. So if I name my function as good enough, my code might start to literally read like English, and somebody who just got on the team or an intern or whatever, they can come in, read the code, and really just like process it way more quickly than it just being a bunch of random stuff on the screen. And like I just said, functions are user defined. So I get to name my function just like I would name a variable. So I give it the best, most concise, but still like descriptive name possible so that somebody reading it can understand what I'm trying to say. And lastly is that it makes our code reusable. So like Brandon said, if I create a function one time and I know I'm gonna need that function repeatedly, then I would just create it one time and I can use it over and over and over again. I don't have to rewrite stuff. So I think your lab this week will be you proving that to me. I'm gonna give you some code and you need to extract parts of it to functions to show me I see this thing is being redone over and over again. So I'm gonna make a function for it. Sounds sweet. Yeah. So now, giving you this diagram, but in computer science terms. So we've been using input and output as like our two terms, but really, what functions our input is called a parameter. Parameters are what we mean. When we say parameters, we mean input. And when we say return value, we mean output. So if you've ever seen the keyword return in your code, hence int main has return 0, that means give something back to the user. Give some value back to the user. So like I said, parameters is just our inputs. Some functions have them, some functions don't. Some functions have them, some functions don't. If you ever see a function and it has something in those parentheses, that means it takes parameters. Not every function puts things between those parentheses, just like the length function. Length doesn't put anything between them, meaning it doesn't take any parameters. And then on the right side, we have the output or the return value. Again, not all functions have a return value. So both of these things can possibly be optional. There can be a function that takes no parameters and it doesn't have a return value. In that case, the parentheses would be empty and the return type would be void. But we're gonna break down like all of those specific cases, but just at a base level, parameters are the inputs, return values are the outputs. So now for calling existing functions. And this should be kind of close to home. These should be the functions that we've seen in this class for the most part. But I'm gonna just walk through examples. So let's say there's this function in CMath called ABS. What this function does is it takes a value and it gives you back that same value, but the absolute value of it. So let's say I put in -1, it will give me back 1. It's taking some X or some input, running it through the function and giving me an output. So as far as syntax goes, I would need to import CMath, or include it. Then I'm gonna call the function, it's called ABS. Can y'all even see this? Is it too dark? Right. And so I'm gonna put my inputs inside of those parentheses. My input in this case is what? -5.5. So what should this give me back? 5.5. Exactly. I provided an input and I got an output. So what would happen if I didn't put anything? What happened if I put nothing in it? Error. An error. Because basically it's going to say, yo, I know what ABS is, but whoever created it said the user is going to give me a value. So if you do not give it a value, it's going to complain. It's not going to try to run any code that comes after it. It's going to stop right there and throw the error. So you have to know what is this function actually, how is it built? Does it take inputs? Does it provide outputs? You need to know how the function kind of works internally, just a little bit, in order to use it first. So now breaking it down, right? I said if I have ABS and I gave it a -1, it will return me that same value, but the absolute value of it. And again, reiterating, if I put nothing in those parentheses, it would be an error. Because it's going to say, I've seen this function before, but I've never seen it not take any parameters in. So I don't know what you're referring to. So it's going to throw the error. And pointing your attention to these last 2 points. This specific function takes one parameter and it has one output value.
So the ABS function, can you put positive numbers in it?
Mm-hmm.
So let's say I put a 4.
Mm-hmm.
What would it return?
Tell me, what's the absolute value of 4? Yeah. It wants to know how many steps away are you from 0. That's what absolute value means. In either direction, positive or negative. But good point, because all the examples were negative. So, any other questions on this slide? So let's take length, for example, right? We know length is still a function that we've been using, but in this case, we've never put anything inside of these parentheses. Or if we use size and length, same function. So what it really wants to know is what string am I trying to calculate the length of? It still has a type of like input in a way because it needs to know what the string is, but we don't put anything inside of these parentheses. We don't put anything inside of those parentheses. So in this case, it does not take any parameters. It takes 0 parameters, but it still provides an output. It still provides an output. So if my string is str and it has 15 characters in it, the output will be 15. The output is going to be 15. So an example of that is, let's say I create my own little string. My string called str has a value of functions, the word functions. I know, since I'm typing this out, it has a value. It should have a value of 9. It should have a value of 9 because it has nine characters. So if I go and compute the length, again, it takes 0 parameters. 0 parameters. If I put something in here, it's going to throw an error. It's going to throw an error. So I put nothing in there, and it will return me one value. It's going to return me one value representing how many characters are in the string, and in this case, that value is 9. That value is 9. So again, no input, but we still get an output. So I need to, like, in order for me to actually do this properly, like use this function properly, I need to know, does this function I'm trying to use take inputs, and what type of output does it provide me with? Because that's how you're going to like really use these as building blocks to like solve some equation or compute some or write some app or program. Like you have to call one function, get a value, use that value to call another function to get a new value. Like it's going to be a process. So you got to know, okay, I'm using this function because this reason. We good on like the functions that we've seen in this class so far? Cool. So a little test. So remember we said length, right? Length returns how many characters are present in a certain string. So what would the parameter types be? And to kind of breeze over that, parameters are your inputs, right? They have a name and they have a type. They have a type. So you're saying it's going to, remember this is length, right? What parameters does the length function take? None. None. We never put anything inside of those parentheses. Hence, the example over here, we don't put any parameters inside of it. Never. Never. What would the return type be? So if I call length, it gives me back a what? Int. Int. So we have to know these two columns at all times. What values do I need to provide this function with, and what is it going to give me back? You had a question? You had a question on that? Oh, my bad. So what about the at function? The parameter is an int? You sure?
Yes.
And what does it return? Yeah. All right, for this last one, substring. Substring, what's the parameter type? 2 ints. It could be 1. So one of them is kind of like an optional. One of them is kind of like an optional because I could just throw one integer in it and it won't complain. And what would the return type be for substring? A string? Exactly. Exactly. So all these functions, well, not all of them, .length doesn't, but each function has its own like DNA or makeup. So you got to know exactly what type of function you're dealing with in order to properly use it. In order to properly use it. Questions on this slide? So now for creating functions. And y'all probably gonna need to pull up that Scratchpad thing, because we're gonna start, getting our hands dirty. So let's see. Let's say I want to create a function, right? It's going to be an add function. What I wanted to do is compute the sum of some given integers, right? I have some integers, and I want the sum of these integers. So think about like what pieces we would need to create this function. Think about what pieces. Not necessarily. Not necessarily. Because if I just want to add two numbers, right, all I really need is the plus sign. All I really need is the plus sign for that. But good thought, though. The core pieces I need is really just the inputs. I need to know what my two integers are. I need to be able to compute it, which is what you said, like the plus sign, how to go from the input to the output. Then I need to take the output and return it back to whoever requested the sum. Take that output and return it back to whoever requested the sum. So in terms of code, this is how I would process that. I would say, all right, what am I trying to do in this case? In this case, I'm trying to add. So I'm gonna start with my function name. I'm gonna keep it simple, so whoever reads my function or uses it, they know exactly what it's gonna do. It's gonna add. So I'm gonna start with my function name. Next, I'm saying, all right, what are my inputs? What are my inputs? My inputs are two integers. I'm given two integers, and I want to add them and return back the sum. So this is how I would write that in C++. I'm gonna start my parentheses, and this is creating the function. I'm creating it so other people can use it. So I'm gonna say, boom, this function is gonna take one integer called x, another integer called y.
So when you did that, you created two variables too?
Like right here?
X and
Yeah,
Y?
this is, basically it's saying if I call this function, whatever I put as the first variable, we're gonna refer to that as x.
Oh,
Whatever I put as the second thing, we're gonna refer to that as y.
That's all it does now?
Yeah.
Alright.
hmm So ordering matters. If I mean for this to be the first thing, then it needs to be like if this was division, this and I named these numerator and denominator, it would make a big difference. You know, adding is gonna be the same both ways, but the ordering matters.
Gotcha.
Shouldn't you use double? Because you know sometimes you add.
If we suspect that we could be adding doubles, then yeah. Let's say this case, and this was really just a space thing, because double gonna take up way more space.
Yeah.
Let's say in this case we just adding integers, right?
Mhm.
So I'm gonna say, boom, this function that I'm creating is gonna take two parameters, two integer parameters. Lastly, I'm gonna say, all right, what is it gonna return back? So if I add two integers together, I know I'm gonna have a result as an integer. And that's what I wanna return back to whoever requested the sum of these two numbers. And then lastly, I'm gonna have the body of the function. The body of the function. So I'm gonna say, I know simply adding two numbers is just throwing the two numbers together and separating them with a plus symbol. So I'm gonna say, boom, do that, and then return it back to the user. So if the user calls my function, they put two integers in it, it's gonna give them back the result of that sum. That is how our functions work. We're about to dig deeper and practice some more, but is it starting to make a little sense?
Yeah.
Is the syntax confusing at all? Is this the most confusing piece
Yeah.
of this? Yeah. So basically,
I have a question.
yeah.
So you have int on the outside and on the inside. Are
Mhm.
we gonna like have any issue with that, or is it gonna know like the separation?
Inside and outside being
Yeah.
this and this.
Yeah.
So this is separate from this. These are all the pieces you need to create a function.
Okay.
So this means this is the type of value I'm going to return. This could be any data type though, depending on what type of function I'm making. Let's say my function wants to return a string. I will replace int with string right there.
Okay.
And this, your parameters are your inputs. That will also change depending on what type of function you create. So let's say I wanted to add doubles like Kaylee said. I would need to change this to double x and double y, because in this case I'm being provided double values instead of integers. So you gotta kind of know what are my inputs and what should my output be for this function that I want to create. So really you want to like write it out before you just start typing up some stuff that you don't fully understand yet. And so because I said my function is going to return an integer, I had to actually have return whatever the sum of x and y is. And so again, x and y only exist within the scope of this function. X and y only exist within the scope of that function. So I can have more functions that I create in the same file, and I use x and y in those functions too, because once the function ends at the very end, those get wiped away. They get wiped away. So going a little deeper into the syntax, again, I start with the return type. That can be int, bool, char, void in some cases. Any data type that we've seen in this class, a return type can sit right there. That type can sit right there. Next is the function name. This is going to be camel case. You want to name your functions camel case. This can be any name technically, but you want it to be descriptive for whatever your function is going to do. You want it to be as descriptive as possible, but still concise so that somebody can remember the function name, right? And then you have your parameters. These are going to be separated by commas. So if you have two parameters, you will have first one, type in name, comma. Second one, type in name. Every parameter needs a type and a name.
Oh, so we don't have to use semicolon for functions?
No,
Oh, okay.
no semicolons. Is going to be commas. So yeah, good point. Because in like the for loop, you had a semicolon separating each part. With a function, you separating them by comma.
Oh, so it really is like English almost.
Yes. Yeah. I guess you can think of it like that. And then everything inside of your curly braces is going to be the body of the function. Everything in the curly braces is the body of the function. So if I have a return type here that's other than void, then I need some return statement on the inside of my function that's returning back the requested value.
What should be return 0? Could it be?
What you mean?
Because you know how you put return 0 at the end of the name.
Mm-hmm.
Would that
Yeah,
be-
that's an example of it. Yeah.
But do you necessarily have to put return 0?
In the specific case of int main, it doesn't need you to
Right.
put it, but for every function you create, you need it.
So like I said, so outside of it main, you do need
Mhm.
return 0.
Yeah. Well, not necessarily return 0, but return, because 0 is not always going to be the value that's being returned, right? Like let's say, in this case, let's say I pass through 5 and 7, right? And I want to add 5 and 7 together. I wouldn't return 0 in that case. I would return 5 plus 7.
Okay.
Does that make sense? Basically, like you need the idea of the return there, but the value that you're returning is not always going to be 0.
Okay.
More often than not, it's not going to be 0. So return statements. So certain functions that we'll see, and I have an example that I want to go over today where a function can have multiple return statements. So you can have something like if some condition, return this. In another condition, return this other value. You can have a chain of if statements inside of a function, and you'll return different values based on which condition is true. But once a return statement gets reached, that function ends. So if I return true on line 3 or whatever, the function doesn't read anything after that. So once the return is hit, that function is over. Just like when you think about int main, you see that return 0 at the bottom, nothing after that can ever be reached, because that means the function ended. That means the function's over. And so the last line, the last line of your function is really going to be a return statement. Like I said, you can have multiple return statements inside of the same function, but the very last line of that function should be a return statement. Some functions will have one return statement. Some of them will have 10. Some of them will have 30. It really depends on, it really boils down to, okay, have I satisfied my condition for this function, and can I exit this function right now? Do I have what I need? And so we'll explore what that really looks like, but these are the ideas behind the return statement. Questions on this piece? So I feel like we should probably, I'll breeze over this, but I really want y'all to start coding so it can really resonate. So really pay attention to the first two columns. The first two columns, I'm saying, all right, these are my return types. The latter 5 we've seen and we've used, but we haven't really used void much. We haven't had to really type that out. We've seen it, but we haven't had to type it. So let's say I have a function that returns void, which means it doesn't return anything. what you might see in your code will look something like void, the name of the function, and then whatever parameters that function might take in. Whatever parameters that function might take in. And so see in the third column, I said an example of a return statement for this one. There is no example of how to return void because void means don't return anything. Void means do not return anything. So let's say I have a function that returns an integer. I would start that creating that function by typing int, whatever the name is, whatever parameters it's going to take in. Whatever parameters it takes in. There's no correlation between the return type and the values that this function is going to take in. There's no real correlation. So one good example of that is the string one, right? This function, what I want it to do is take in a bool value, let's say true or false, and convert that to yes or no. So there's really no relationship. Between a string and a bool, but I'm creating that relationship with this function. So don't think, oh, because my function returns an integer, my inputs are integers. Like that, it's not that easy. You have to know what you want this function to actually accomplish. Likewise, for this last example, I'm saying type in or give me a day of the week, and I'll return true or false whether it's a weekday or not. So it's like I'm creating this relationship between the input and the output. I'm creating that relationship. Questions on this slide?
For the void, like, what would be like a purpose for using it if it doesn't return it?
Perfect. Got you right here. I knew it was gonna come up. Hey, I be ahead of the game. I be ahead of the game, man. So again, these don't return any values. They just do stuff. They do stuff for us, but it's not like the user is requesting anything back necessarily. And so I have these examples that I thought of just for you, Brody. So let's say the first one, right? Open browser. Let's say I provide the name of a browser, Firefox, Safari, Google Chrome. And I want to just type that in. Let's say I type that in the ASM, and I want this to read that value and just open up a browser for whatever I typed in. There's no value that it needs to return me, right? It's just like I type in something and it does the job. I'm not sitting there waiting for a value back.
Okay.
So open browser, I'm gonna give it the name of a browser and it's gonna open it for me. That's it. Job is done. Likewise for the second one, deliver a package. I'm gonna give it an address. And it's gonna deliver the package. That's it. I'm not sitting there waiting for a value in return. I'm not waiting for a value. For login, I'm gonna provide my username and password. It's either gonna log me in or it's not. I'm not waiting for a value back. In some cases, you might have like a login function that returns something like a successful or not successful. Like it might return a bool, and that means true if it's successfully logged in. But in this case, I'm saying I don't want anything back. You either gonna log me in or you're not. That's it. So these are like some examples I could think of cases where like you're not sitting there waiting for anything back. You know what you want to do, and it just needs to get done, and you can carry on doing whatever you're doing in the background. That makes sense?
Yeah.
Cool. So I've showed this before, but let's see if it's more applicable now. So int main is where we always start in our code, right? Int main is where we always start. We have these functions or other planners that we can go to for specific reasons. So we know that, if we go over here, this is gonna allow us to get an age. It's gonna allow us to get an age. This one is gonna allow us to get a name. This one is gonna allow us to work. All of these functions or planets exist for different reasons. But we reference them by name to be able to go to these places and come back with some value. So in this case, if we go over here, we know we're coming back with a string. We're coming back here with a string. Likewise, for get age, we're coming back with an age, an integer. Lastly, for work, we're not coming back with anything. We're just going to work and we're coming back. That's it. We're not coming back with anything because it says void. Void means I'm not returning anything. I'm not coming back with anything. So if I wanted to get an age, where do I go? Help me out, help me out. Get age, of course. And after I go over there, I always have to return. So at the end of this function somewhere, I can kind of see it in my head. There's probably a line that says return age. At that point, that's me going back to int main. That's me going back to int main. Likewise for get name, I can go over there and get a name. I can go over there and get a name. Once I reach the end of that function, it's going to say return name. At that point, that's me going back to int main. That's me going back to int main. This last one is tricky because it's like I'm gonna go over there, but there's nothing in there telling me to return. It's not. Basically, it's gonna see the end of the function, the curly brace, and then it's gonna be like, all right, like I'm not gonna keep waiting. It's time to go. So it's gonna go back home, but not in the sense that it's gonna say return anything, because void never returns anything. This is the concept behind functions and like how they return back to some origin. How they return back to some origin. So the code for this, let's say I wanted to call a specific function. Let's say they've been created already. And let's say this function get age is going to give me somebody's age. Let's say in that function it prompts the user for their age and then it just spits it back out. It returns it back. In this case, if I call this function, I know get age returns an integer. So I have to take that value and assign it to an integer in order to save it. Otherwise, if I never did this piece, it would call the function and it would just be like lost. It would be lost. I have to write it down or like save it somewhere. I have to save it somewhere. Likewise, with get name. If I'm gonna call this function, I need to take whatever it's gonna return and save it. I need to save it. So anywhere in my code down here, if I wanna print user's name is blah, 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 and their age is blah, 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 I have these variables now with those values. I have variables with those values because I got them from the function. I got them from the function. So now we about to code for real, for real. So let's take like 60 seconds to 2 minutes to think about, go back to that vending example, right? Let's see what inputs and outputs will we need for like a vending machine. Think about the types of data you're dealing with for a vending machine and how that could work. Think about how that could work. You punch in the code, you say int. Give me an example of like an
And
int.
chars too.
Right, it could be a mixture of chars and ints. So what does that mean?
Like C2.
So if I have a mixture of chars and ints, what is,
String.
okay. So that's what, the input?
That's a return. That's a return, right?
They said, let's say I have like C2 as my input. So if I input C2, that's my input, my parameter. But what am I actually getting out of the machine?
Oh, the string.
This, food,
Yeah,
snacks,
whatever.
drink, whatever.
The thing is like,
How could I represent that? Don't overthink it.
Input received. I can tell you like
Return chip.
Okay, what chips would be what?
String.
Okay.
String.
Okay, alright, bet.
There we go.
it's food. It's food.
Yeah. That's probably the easiest way to like represent it. So this is what I said. In my head, this is kind of what I saw. I say I know my inputs are a combination of characters and integers, so I'm gonna just use a string. I'm gonna just use a string, and I'm gonna say, all right, if the user types in A1, I'm gonna output Twix. Likewise for A2, I'm gonna output Skittles. This is probably the best way that I can like represent this type of input-output relationship with just like the basic types, like int, bool, char, string. But if they enter anything else other than these four, I want to tell them sew it out. I want to tell them sew it out. So we gonna code this one as a unit, as a gang. Yo,
So would this be like a whole bunch of if statements or like,
you think so?
I mean, you know more than
Nah, you know, shit, I don't know. I was about to ask y'all. I don't know. I was about to ask y'all. I'm not gonna lie. I think, shit, that sound right to me. All right, let's boot up. Let's boot up the scratch pad. Scratch pad time. Yeah, I don't be knowing this stuff for real, so.
Yeah, function.
We got it. We got it pulled up. So let me see if I could pull up the little jump. Can I like? It's not all.
Like zoom in.
That jump all in the way.
Workspace.
Oh, all right.
I know, like, you did, like, the little thing.
Sheesh, like,
Press workspace.
huh?
You're trying to make it split.
Oh, my bad. I'm burnt out. All right, bet. I'm thinking that was a look.
Oh my lord.
All right, bet. My bad, y'all. Unc be tripping sometimes. All right. All right, boom. So we're going to try to replicate that type of logic in a function. We're going to replicate that type of logic in a function. So how would I start writing that function? And just as a quick note, if I'm creating a function, it goes on top of int main. Every function I create goes above int main. Yeah, int main should always be the last one. So, all right, how would I start creating this function? And remember, you start with return type, the name. So it's returning a string.
Yeah.
We sure? String.
Yeah.
All right. Okay. What's the name of this function? Get snack. I like that. Get snack. And so, does this take any parameters?
No.
No.
Well, yeah, wouldn't it be the int and the char for the
Well, it has
parentheses?
took one, yeah. Technically?
Should it?
Yes, yes, it should.
What's the input? Y'all took.
Strings.
Right. Okay.
It could be like string snacks.
Don't guess. Don't guess. What does your input represent?
It's a string snack.
String row?
I'm looking for something specific.
Quotation marks?
It's like the code. It's the code. The item code, or yeah. It's like
ID?
I'm looking for like what we should call, because we gotta like descriptively name the input. We know that the input in this case represents like an item code or like a
Button combination.
yeah. Okay, yeah, cool. Button combo, item code, something like that. No, I wasn't saying no. I wasn't saying no. However you choose to describe it, make sure that it's something that somebody else can see and say, okay, I have an idea of what should go right here. Because if, let's say I just named this string X or something, like I left it vague, it would be like, yo, what am I supposed to type in here? So I'm going to say, dang, y'all gave me a good one. I'm going to say item code. I'm going to say item code. We cool with that?
Yes.
Huh? You say, all right, bet. So everywhere inside of this function, if I want to refer to the input, I would use item code as the like variable.
But wait, don't we still have to do the int for the int part of it, or not?
What int part?
Well, it's AI, or like a something.
We're using all strings.
Yeah, it's just a string.
I think the number is going to be a part of the string.
Right,
Yeah.
right. Everything within the quotes is the string.
Oh, okay.
So the user is giving me some item code, and I want to return them back the name of a snack, right? So how would I start writing that one out? What we thinking?
See,
You prompt the user.
What we need to prompt them for?
the numbers called input.
We already got the input. When they call the function, let me show you. Let's say, I'm gonna actually just show an example. So basically, if I call a function, I'm gonna give it a string. So let's say I type in A5. This is how the input
Oh, you were
Input.
working in main.
Yes.
Okay.
You call your functions that you create from int main, and you give it a value. Because remember, this says give me a string, so I'm going to give them a string.
Oh.
I'm going to give it a string. And since this function returns something, I want to actually save that. I want to save that. So I'm passing through A5, and I'm expecting something in return. But I still got to write the logic to be able to do that. I still need the logic, so help me out. We did the header right. The header looks good. But now I need some logic to check the input and give the specific output based on that chart. If
Get snack is equal to
doesn't exist yet, we creating it.
oh,
What thing do we have that has the
item code is
if item code? Thank you. If item code what?
is equal to like whatever you need. So in this case, A5.
Where you get 5 from?
A5. Sorry, A5.
A1. Because we're trying to match this.
Oh.
We're trying to match
I
this.
just did set A5 because that's what you already had.
Nah, don't even think about what I put in. That's just like that's gonna get handled here. Well, it should if we write this correctly. The cases we know we want to handle or rip are A1 through A4. So I'm saying, okay, if the item code equals A1, then do what?
CL like
We're not doing C out no more. Return. Return what? Like that?
I can tell you.
Yes, that's it. All right. So if A1 was the code, it would return Twix and stop right there. It would stop the whole thing.
Yeah.
So, all right, what do we need to? That else. Else if what?
We do the same thing though with
All right, bet. We following? So now I'm pretty much checking each case to make sure, okay, if the user gave me this value, I'm gonna return them this. If this, return this. If this, return this. So I'm pretty much making the vending machine essentially. So that way anybody in the future, they don't have to recreate all of this from scratch. They can use my function. All they need to remember is the name and what to pass into the function. That's it. So I'm making this for the people, man. We for the people. Functions is how you provide for your people, man. So A2 gives me Skittles, man. Skittles. Else if,
and it should just be a whole bunch of these.
yeah, for this specific function, yes. Every function is, a little different, man.
Is there a way where it's like you could have it like store all the values and like know what each of those is, or is that something else entirely?
Yeah, probably in like CS2 or something like that.
Just ask that's all. Just so we ain't gotta constantly write out item code equal to something.
All right.
I'll just store it
Let's
all.
see. See if y'all catch this. All right, so is this right?
You're not gonna do Snickers.
Oh, Snickers, my bad. All right, so is this it? Oh, my bad. I'm trying to rush to the trick. All right, so is this it? Boom, we got.
Are you supposed to put CL?
Good point. Good point. No, we're not supposed to have C out. Good catch. Making sure y'all, on point. We need to return sold out. We're gonna return sold out. So every case needs a return statement. Otherwise, C++ is gonna say, there's a chance I got to one of these cases and I didn't know what to return.
So basically, you would use a C out until you get to the in main. Basically.
Yes, exactly. You won't use C out until you get to int main. So if you want to know what did this thing give me back, you could do C out, snack, inline. And what this is going to do is take this function with this input. It's going to jump all the way to the function and start executing line by line. And I'm gonna show this live. But does our function look good? Function look good?
You need semicolon.
Oh, I bet. My bad. All right, so what I'm going to do is see if I could just hit it with the wham bam. Let's see if I might need that. Let's see. It's something that EdStem allows us to get away with, but I don't think some online compilers like it. So let's see if this is good code. All right, boom. So looking at the execution of all of this should take me step by step through the code. So what this says is, it's starting from int main. We know int main is always our start point. And keep track of like this little red arrow right here. So starting from int main, it's gonna work sequentially. It's gonna go step by step. So it's gonna say, all right, we wanna create a variable called snack. But the value of this variable should be provided from a function called getSnack. GetSnack is going to give us the value. C++ is going to say, hold, where is that at? So what it's going to do is jump all the way up. Y'all saying that?
Yeah.
Let me replay that. Boom, it's going to jump all the way up and say, all right, I found it. It's going to say, all right, I found it. It found the function that we created. What it's going to do is, it's going to step through it line by line. It's going to say, is this true? And remember, our case is A5 is the input. So should this first if statement be true? No. So it's going to check the next one. Is this one true? Nope. 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 So it has to be this. It has to be this. Boom. It's going to jump to the end.
I have a question.
Yo.
In the statement, in the cout, we have cout snack. But at the top, we have getSnack. Does it know that, like, that part of it is connected to it? Because I know C++ is, like, case sensitive and whatnot, so. Like it or what?
So you talking about
Right there, it says just snack. But at the
right
top,
here?
we have it labeled as getSnack. So does it automatically like know, okay, go there?
Nah, there's no, the way that I name them doesn't create a relationship.
Oh, okay.
Just because I said snack and snack, that doesn't, like,
You do a keyword smash.
yeah,
Oh, okay.
that doesn't make them, so let's see. But yeah, basically, what it's gonna do is go through, once it sees the function is being called, it's gonna go to that function and start executing line by line. It's gonna execute line by line. So let me see if this, let me see if I got like I think I need what's in there? Boom. So I got my output of sold out because my input value is A5. So let's say I change this to A1. If I change this to A1, I'm expecting it to output what? Twix. Any questions on how we did that before I go back to lecture?
So we were able to put A1 in the function getSnack. So is there a solution where we could ask like a C where we could ask the
Mhm.
user?
So there's two ways I could do that. I could leave my function alone, and I can do cout enter a snack, and do cin snack, and in that case, I would just need to create snack up there. Then I can say get snack, and instead of just hard coding the value, I could just put in the variable like that. So basically what this is saying, we've seen this before, right? Just prompt the user and store it. Then I'm gonna say use whatever they entered and use that as the snack instead of me like trying to guess what they put. And so let's see what this does. It's gonna say enter a snack. So let's say I enter A2. Why did it print out A2? Let's see. My bad. Technical difficulties. Oh, I didn't save it. So remember, I gotta save. This is gonna return me a value, so I gotta save it. So what I'm gonna say is, man, scratch whatever the snack originally was, calculate the real snack, and assign it to that variable. Save it to that variable. Nah, because I created it already. So once I create a variable, I can't recreate it. So I could do I could create a different one with a different name. Let's say, let's do it like this actually. Let's name this code. Enter a snack code. It's gonna save it into code, and I'm gonna use that code to get the snack. Did I just lose somebody when I just changed that up? Oh, I bet. So basically, I'm saying enter a snack code. I'm gonna save that to code. I'm gonna use that code to get the snack. So like how you name your stuff can make that much more of a difference in terms of somebody being able to understand what you trying to do. So I'm saying use the code to get the snack. So if I run this and let's say I type in A2, now it gives me back Skittles. If I type in A5, it should tell me it's sold out. So if I wanted to, let's say, get 100 snacks, or like I could just copy this over and I could use this function as many times as I want because I created it once, and it's dynamic enough that I can put any string into it and it could give me exactly what I want. So that's the point of the function in this case. I mean, technically, I could just have a whole bunch of if-else statements inside of int main like we've done in the past, but like, I don't want int main to be just about snacks. You know what I'm saying? So like, I'm gonna move that specific stuff to a different function and only call it when I need it. So really, in real life, I didn't even need to call that function if I didn't need it. I can always create it for the future. And C++ will always know about it, but it's not going to use it until I say use this specific function. It's not going to use it until I say use that function. We good on that so far? Cool.
Wait a minute. I tried to run it and it's giving me go to the bottom.
Oh, you're alright.
Where you even go? Thank you.
Oh, there you go.
It says it's giving me an error saying that my word snack was not declared, but it's like
Hold up. You said, is that how people do what? What's a strip?
I made a string code, enter the snack code, see it.
Oh, a script.
And
Like
then
different
string-
functions? Yeah, most likely. You got it?
I did.
So string code, CRC code, code. Yeah, you never commented the function.
Yeah, because I tried running it and when watch this, A3 will give me
So you put
2, 3, 4. That means something's wrong with this.
so you put because you put A5 in there. You gotta use the code that you actually typed in. So if you get what I'm saying? Like you hard coded the A5 in there.
I didn't see that part. Thank you. Yes.
Let me try to breeze. We got 5 minutes. Let me breeze, and then I'll be around for questions. Dang, my bad. I don't know what's up with this jump. Oh, I be acting like I don't know how to use a laptop. All right, so we did that. We saw the code visualized. All right, boom. So the last thing was just functions practice. So in ISTEM, I put up a slide that says functions practice, not graded. This is for you to practice functions before you like jump into the homework. I gave you like some scenarios, and I want you to kind of pick them apart and figure out, okay, in this scenario, what would my input be? What would the type of my output be? And what does the body of my function need to look like? So this is like good reps for even preparing for interviews. Like your interviews is going to be you writing a function that does a specific thing. So you want to get used to writing functions a lot. Always think function first. So I'm going to go over the first one first because we kind of already did it in lecture. Then I'm going to throw the homework up because we only got like 5 minutes left. So actually, yeah, feel free to help me out with this first one while we at it. So this says create an add function that accepts two int values and returns the sum of those values.
So you would do int add,
Int add.
and then you would put int x, comma,
Or,
y, right?
my bad, I shouldn't have put this in the slides earlier. Alright, so and then what goes on the inside?
Return x plus 1.
What if I want to create a variable for the sum and then return, let's say I want to do this. Let's say I want to calculate this sum first, then return it. Like that? The int.
Oh, yeah.
Wait, wouldn't it be double?
You got me this nothing.
Why?
I'm just saying like for the case.
Nah, it says the function accepts two int values. Remember, you can't add two ints and get a double. You with me?
No, you're good. I was thinking like past.
So yeah, like really ponder on what the thing is telling you. Yeah. So like don't like see int and then ignore it and think double. You know what I'm saying? Like process what it's asking you for. Because if the user says they want something and you give them something different, then at that point, that's you know what I'm saying? Like. So in this case, boom, what I'm doing is I'm adding first, and I'm assigning that to a variable. Then I'm saying at the end, just return that variable. Return that variable. So I chose to do it this way this time because in the slides I said just return x plus y. It's the same thing. It's the same exact thing. But this, I just broke it down into 2 steps so you see there's different ways of having it. We want to do the second one or y'all want to just...
Do the second one?
Want to do it? Bro said, yeah, we got it. Alright, this says create a function that prompts the user for their first and last name separately and returns them as one string. So what's the return type of this one? String. What are we going to name this one? Get full name. Okay. Does this have parameters? You sure? Technically, yes, that would be a way, but this one is saying it's going to prompt the user for their first and last name. So in this case, we're going to have something like this instead. Y'all see where I'm going with this? If the question didn't say prompt them separately, then yeah. So I kind of phrase these in a specific way so you have to use certain tools. I'm limiting you to using certain tools. And so, all right, I got the first and last name. Now what do I need to do? Return first plus last. And so, just nitpicky, I probably would throw the little, throw a space in there. That makes sense?
Yeah.
So yeah, this is a little jump start to the homework. Give it a try, and then at the end I put some leak code questions on there. This is like real interview prep. So for y'all who plan on doing technical interviews at some company, these are the type of questions you're gonna get. Create me a function that does X, Y, and Z. These are your inputs, and you need to figure out how to write the code and give some output. That is what a technical interview looks like, for the most part, especially at Google. So give those some practice, and then start stepping through the homework and see what you come up with. We good? And last but not least, your homework is what I just showed, but also the Wordle project. Start getting a jump on that. Meet with your TAs to go over your docs, and then so you can start coding. And then scan this internship stuff. So these I think this over hundreds of internships you could just literally scroll and apply as you see fit.
What we doing?
MSC.
I need to stop using it. I say that too many times.
I'm about to come over here. All right, y'all. See y'all.